about we'll be talking about the topic is for related to system administration, and then one topic of system administration is how you manage your file system. So tonight we'll be talking of about uh, one file system that is mostly, I mean, that use in many organizations, especially for the enterprise, because it has many good features compared to the traditional file system, which is the ZFS. I pronounce it ZFS because yeah, it's pronounced Z as Z. But from Americans, usually they call it ZFS, Zettabyte File System. Okay, so this will be the agenda tonight. So we'll be talking about the file system. We review some of the traditional file system. Uh, yeah, as you can see, the slide will be dry because I lost some of the objects on it. But I will upload with the complete one. Yeah, okay. File system, and then traditional file system, and then volume manager, and then the ZFS. About the GLC, we are Gadalita Chakrawala. For those who are new to GLC networks, we are doing training and then consulting, and then we do MikroTik, Ubiquiti, and Linux. Okay. We also do events like what we are doing on Thursday evening. About myself, my name is Achmad, and I'm based in Bandung. I'm a Linux user, MikroTik, networking, and system administration. So in the beginning, I was a system admin. So mainly I was responsible for doing system administration, Linux space. And then by the time goes, and then we need to expand our responsibility so that we are not only responsible for sysadmin, but also networking, managing Cisco and MikroTik, Ubiquiti, and then also doing some programming. Guys, if you have LinkedIn, and then I would really love to connect with you guys. So yeah, to open a new opportunity, to open a new, um, uh, a new horizon, broaden mind. So if you have LinkedIn, then we can connect together. Um, about past experiences, we do a network, managing a network installation, configuration, um, integration with other components, and then yeah, um, and also set up some automations within the network. Okay, about the webinar itself, we started from 2010 with various topics. If you like to involve, share a webinar, and then you're really welcome. And about yourself, I can see some of you are from Africa, from India, from Pakistan. Thank you very much for coming. Again, really appreciate you your join here. All right, so let's talk about the file system. So before we talk about file system, we need to talk about the one component of storage, right? So when we talk about operating systems, one component is hard disk. I mean, it's a storage. And then when we talk about storage, most likely we will be talking about hard disk, right? Even though with the cloud environment right now, most likely you don't care about is it hard disk or not. As long as you connect to the internet, you put your files, everything on cloud. But if you take a look at the cloud itself, actually there is no cloud, right? It's just other person's computer. And then every computer must have a storage. And then in order to put some data on storage, usually you have a physical a device named hard disk. Now hard disk can is already involved into several forms. Uh, in the initial form, they have a platter base like this. Now they have SSD, so there is no moving parts. Like this is the motor, right? And then this is the platter, and then they have three platters here. And then we put the data on the platter. So when we take a look more closely, and then we need to understand if you open a BIOS and then the BIOS detect the hard disk, right? So initially a hard disk consists of several platters. For example, this is the first platter, second platter, third platter, and then every platter they have a structure, a circular structure like this, and then this structure consists of a track. So this is one track, okay, and then they divided the track into sectors, okay, and then if you put the track, same track, for example, this is the track right here. If you have several platter and then several track can be grouped together, become cylinder. So these are three parameters that is commonly used for managing the hard disk. Sorry, I have a comment here, mute. Can anybody hear my voice clearly? Okay. I don't know what's going on with your PC. But everyone here can hear my voice. Right, so perhaps you can restart your laptop and then connect again. So these are three parameters which you are using for um, managing your hard disk. Okay, so cylinder, sector, and then track. Every operating system understand these components, these parameters, and then these parameters is related to uh, the physical hardware. So it's nothing to do with the what is it? Nothing to do with the operating system. So it's just a purely hard disk component. Okay. So after we have our hard disk, and then the next thing is we need to set up a file system on that. So yeah, this is the file system. So file system is a part of operating system. So it's an abstraction of files. So why is it called file system? Because operating system consists of files, right? So what files? It can be in Unix. We talk about Unix. So we have a FHAS, file hierarchy structure, where Unix has a slash as a root directory, and then below they have another directory, for example, home, right, slash etc, slash var, right, slash usr, and then so on and so forth. So those are the file structure. So basically, operating system consists of files, right? So therefore, they have a file system for managing those files. Okay, makes sense? Even the kernel. Okay, so the kernel, if you go to Linux operating system, the kernel is located at the /boot. okay, slash kernel something. So there is a one file, and then during the boot time, we will load the files into RAM. And then after the, okay, so let's talk about the boot sequence. So you have boot here, okay, and then the boot will doing boot from hard disk, okay, from the disk. And then there is a outer sector here, the first sector of the hard disk here, for example. And then you put a program here called loader, okay. Previously, we call it Lilo, okay, Linux loader. Now it's Grub. Others operating system, they have their own loader, okay. So the BIOS will read this one, okay, grub, and then the grub will have their own configuration, blah, 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 blah. And then one of the configuration will execute kernel, and then the kernel is loaded into RAM, and after that, it will load other modules, okay. Drivers, after kernel is loaded to RAM, and then it will initialize, or not initialize. Yeah, you can say initialize because previously RAM is empty, right? Initialize drivers. Why we initialize the driver? Because we need to access those hardware, right? Hardware, yeah. So we can access the hardware if we have the driver. So we will load the driver, and then one of the driver is the driver for storage. Here, other driver can be a network. Other driver can be encryption. Okay, other driver can be printer, and so on and so forth. Okay, so that's the boot sequence, and then, oh, okay, after you load the driver for hardware, and then on top of that, you put a file system driver. So it depends on the file system you're using. A file system can be, can be many, because you can have many options for file system if you are using Linux. Okay, so when we talk about traditional file system, okay, when we let's say let's say you are using a new Linux, okay, and then what you will do, you will install a Linux on a hard drive, okay, so this is a hard drive, and then this hard drive, as you see before, it consists of sectors, right? Sectors and sectors. This is sectors, cylinder, okay. Okay, so they have a cylinder, and then they have a track, and then sector. Okay, so here's the sector. Yeah. So we are based on this sector. So let's say you're doing with a traditional file system. When you install, for example, it's already done, and then you have a second hard disk. This is primary, and then this is the secondary hard disk. Okay, so you will do the same. What you will do, you will do partitioning. So let's say partition 1 is sector sector 100 to 200, for example. Partition 2 is sector 201, to, for example, 300, okay, sector. So actually you are partitioning based on sector, but problem is not the problem. But when I do partitioning, I never say I started from sector this to sector this. No. What you will do, but the system is smart enough to identify which the first sector on that hard disk you can use. And then after that, you just define how much space you want to use. So for example, start from this sector, you will add, for example, plus, for example, 10 gigabyte of space. Okay, and then the software, for example, partition F disk, or on Windows you have, I don't know, File Explorer. Yeah, for doing partitioning, you go to Computer Manager, and then there is a tool for managing the partition of the hard disk. Yeah. So when you define the size of the partition, the tools will automatically allocate the end sector. Okay, so this is how we define the a partition on traditional file system. So it's very easy, very simple, but it's not flexible. Okay, why it's not flexible? Because, for example, you already allocate 10 gigabit, then gigabyte, sorry, and then this partition is already full. Okay, so already 99% or 100%. You cannot write it anymore. So what we'll do? Well, you have to destroy. You have to move the data to other hard disks, and then destroy the partition, and then create the partition again. However, in other partition, there are lots of spaces. Okay, so it's a kind of dilemma. So you have partition 1 here is 100% full, but partition 2 only 10%, right? So with traditional file system, this is not flexible. Okay, so that's why it comes the next tool. It's called Volume Manager. So with Volume Manager, you can define flexibility of managing file system. So basically what the LVM, it's called LVM. Okay. So what the LVM promise to you guys as the user is to provide a flexible way to manage the operating system. How to do that? So they are providing abstraction. So previously, this is hard disk, and then partition, and then file system. Okay, so it's very easy. In order to set up a partition, you have to define the start sector and then end sector. It's very easy, very simple. Okay, start and then end sector. As simple as that. You format and then format the partition, and then you get the file system, and then you can put data. It's very simple. Okay, but with LVM, no, it's not like that. So you have a hard disk. Okay, this is a physical hard disk, and then this hard disk must be converted into the physical volume. Okay, here, physical volume. After this physical volume, you have physical, VG, volume group. See, volume group. Okay. After this volume group, and then you have LV. Okay, it's logical volume. So PV, VG, LV. Oh, it's very funny. And then you partition this LV. Okay. But, well, the LV itself is sizable. Okay, so you don't have to define any partition. So the LV itself, you can define the LV. When you define LV, it comes up with the size. Okay, so with the LV here, you have size. Okay, after you set up LV and then you format, and then you format, and then becomes the file system. I just delete it. So file system, okay. So these are the steps. So you compare this, okay. This is the traditional. And then you have LVM here, okay. So what makes this volume manager flexible? This one here. So the one that makes flexible is the LV. So when you define the LV, you never define sector. So you just define, okay, I want an LV that has 10 gigabit. Oh, 10 gigabytes already full. Okay, let's increase to 15 gigabyte. Done. As long as of course, you cannot exceed the physical limitation, right? So yeah, the total LV should not exceed the physical hard drive. All right. So yeah, so this is what the LVM offers, a flexibility. So it's not only bounded by the sectors. Okay. But again, the drawback for this logical volume manager is adding complexity. So previously, just know that, okay, you have partition, format, and done. You can just use it. But with LVM, no, it's not like that. You have to set up PV, and then VG, and then LV, and then the file system. Is it possible to increase the volume group here? Yes, it's possible. You can set up another PV, so it means another hard disk. And then this hard disk will be assigned to volume group. So it means that there is another way to increase the capacity. See, so it's much flexible. So for example, you have two hard disks. So 1 terabyte hard disk. This is 1 terabyte hard disk, 1 terabyte hard disk. Okay. How can you make a partition that has a space of 3 terabyte? How can you do that? Okay, with LVM. With traditional partitioning, you cannot do that. Okay, maximum file system that you can use is only 1 terabyte here, or 1 terabyte here, or 1 terabyte there. You cannot combine. Okay, so that's the drawback of traditional file system. You cannot combine those hard disks into one big volume. But what happens if one hard disk is lost, and then this is lost? Well, for that one, we can do like a RAID, okay? Random, and not random, redundant array of independent disks. So we have a RAID 1, see? Well, maybe next webinar we'll talk about the RAID. RAID 0, RAID 1, RAID 5, RAID 10, okay? We're not talking about the rate now. Just talk about the file system. Then we will not talk about the logical volume manager here in depth, because our focus of webinar today is the ZFS. Okay, so hopefully you can follow the materials, hopefully. Right, now let's talk about the ZFS or ZFS, as I'm saying that. Zettabyte File System is a file system originally created by Sun Microsystem in 2000. I used ZFS long time ago. First time I used on Solaris operating system. It was in 2006, if I'm not mistaken. Yeah, 2006, 2007. Yeah, because I remember during that time, we have Open Solaris user group here in Indonesia. Yeah, a long time ago. So I do a presentation for the community. And then 2006 also was the time when Sun Microsystem now is acquired by Oracle. Before Oracle, it was Sun Microsystem. Yeah, they have lots of innovative products, but they have financial problems. So that in 2009 or 2010, Oracle bought them, and then yeah, it's a very sad story. But yeah, we just continue to what we have. So at that time, 2006, ZFS is the most advanced most advanced file system in the world, and nothing is still today, because other file system, I don't think they have comparable features to the ZFS. So I think started in 2000, 2006. Okay, Sun Microsystem. Okay, so I was a Sun Solaris engineer at the time, so that's why I know. What the ZFS provide first is end-to-end data integrity. So they have a checksum and then copy on write. They have a disk scrubbing. They have RAID set protection. So I'll be talking about the copy on write and then disk scrubbing later. Okay. Also, the administration is easy because they combine file system, RAID, and volume manager into one single interface. Okay, so there is no need to FS tab, which is very cool. In 2009, I was in Australia, and then there was a kernel conference. I attend the kernel conference, and then one of the speaker is from Sun Microsystem, and then everybody was fascinated with the ZFS because of the feature. See, so it's very easy for us. So there is no FS tab to say mounting and then set up things like that. And also ZFS only have 2 commands. So if you use LVM, you have lots of commands. Okay, you have to do fdisk, right? After fdisk, you have to pv something, pv display, pv create, pv remove, pv whatever, and then you have vg, right? Volume group create, vg display, vg whatever, and then you have lv. You have lots of them. Okay, many commands, but in ZFS the commands just only 2. First is pull, and second is ZFS. So ZFS concept is you have a hard disk here, Okay. And then on top of the hard disk, you cannot directly consume the hard disk. So instead of directly consuming, you set up a pool. Okay. So it's similar to file manager. Okay, where they have a volume group. Here we call it pool. And then after pool, and then you have file system. But the file system here is very, very flexible. Okay, you don't have to format them. Okay, once you set up, once you set up the ZFS, it's already have their own file system. Okay, so you don't have to format them, and then you don't have to set up a mounting, right? So in the traditional file system, so you have to do mounting. So for example, /home. Okay, so you have to mount it to /s dev sda. Okay, mount it to /home, right? So with ZFS, no, no need. So that's why we were very amazed with the features of ZFS. And then this ZFS, okay, they have a web interface. Also, they have features like a snapshot, clones, export, import, migration. Okay, yeah, lots of features, and these features are very, very, very amazing. I mean, in my point of view, yeah, because compared to traditional file system, this is very advanced and then easier. Okay. Next is immense capacity. So, sorry, before we go further, just remember the ZFS. So here, the philosophy for ZFS is to manage storage. Sorry, my hand. Storage like RAM. You know RAM, right? Random access memory. Yeah. So you have a piece of RAM here, another piece of RAM here, another piece of RAM. Okay, what do you do with RAM? Okay, so this RAM has, for example, 3 gigabyte RAM, 3 gigabyte RAM, right? 3 gigabyte RAM, right? This is RAM. A question for you, do you have to format your RAM? No, right? You just plug and play. You put RAM here and then total will be 333 equals to 9 gigabyte. Okay, if you remove and then the capacity will be 6 gigabyte. Right? It's easier, right? Why don't we manage the storage like a RAM? Right? That's the philosophy behind the ZFS. Make it easier because LVM is too not difficult, too complex. Okay, so that's the philosophy of ZFS. Oh, okay, which is good. And they are working on that very hard. And then on 2006, they open source the source code of the Solaris operating system. And then it became Open Solaris. Okay, let's get back to the ZFS. Sorry. Yeah, I spent many years with the Solaris operating system, so I speak a lot about that. Sorry. So what else? It has immense capacity, 120-bit metadata. It has compression. It has deduplication. So it means that if the sector has the same pattern, and then you don't have to write the same pattern in other space, so that you can save space. High performance, intelligent prefetch, so that it's like a cache, right? So like a cache. So yeah, as in yeah, if you have ZFS, the ZFS will cache the I/O so that the uh, the reading will be faster compared to traditional file system. But not a drawback. But if you want to use a ZFS optimally, you must have enough RAM. So RAM is one requirement, big requirement for ZFS. So RAM. So put RAM as big as possible. So it's not only used for your application, but for ZFS file system. So ZFS requires RAM in order to achieve high performance. And then this RAM must have ECC or EEC. ECC, right? Error, correction, and check. Yeah. Yeah. So you must not must. If you want to have a fully functional ZFS, so the RAM has to be ECC because many calculations are done in the RAM. Okay. So let's continue. Okay. So this is the copy and write. Oh yeah, one benefit of ZFS is no FSCK, which is very cool. Okay, no file system check. So if you lose the power, usually the file system will do FSCK, right? File system check. But with the ZFS, you don't need it. Why? Because ZFS is using cow, copy and write. So this is one example. This is the initial block. So when you write in a file system, you're writing based on the block, okay? And then every block will be located in a sector. So yeah, so when you want to rewrite the data, okay, yeah, so when you want to write the new data, so the data here will be writes a copy, okay? So it's not replaced. In traditional file system, you have a block here, okay, and then you write on those blocks, right? Okay, so when you want to make a modification, for example, you open a notepad and then you write some code and then you save, and then this block, okay, will be rewrite. Okay, so we just rewrite the current block. Simple, right? Yes. Yeah. But what happened during the time you are doing operation uh, with your files, and you have a blackout. Blackout means power off or hang or whatever. So you have something here during your operations. What you will get, you will get a bad file system, right? Which you have to do a journal. Okay, so before FSCK, so you have file system, and then the file system must have a journal. Okay, and then with this journal, you do FSCK. Okay, so FSCK is done better if you have a journaling file system. So a journal is like, okay, I write this block, okay, I write the journal, I write this block, and then I write the journal, and then when you have hang on your operating system, your file system crash, I mean your operating system crash, And then the operating system will check, oh, okay, so this is the last block that you have modified. Okay, so that I can trace from here, what are the files changes, and then so on and so forth. Okay, so that's was happening in traditional file system. But with ZFS, okay, so this is the original block. The ZFS operating ZFS file system, sorry. So they're not rewrite the old block. Instead of rewrite, okay, so they're writing here in the another block. Okay. Okay. So they're writing in other blocks. So instead of rewrite this is the old block. So they're writing in the different blocks. Okay. Here, for example. Okay, after you finish, and then you change the pointer from here to here, which is cool, right? So this is the check the original pointer, and then they merge. Okay, so as simple as that. So with this method, we are not touching the original, we are not changing the original block, right? Very clever, very smart. So the original block will stay the same. You're writing in the new blocks. If there is a crash, and then no problem. Why? Because the original block is still the same. We just roll back. So that's why it's similar to like a transaction. We call it transaction. So it's like a transaction in database. So you have to write all of them here 100%, and then you update. If not 100%, there is an error, and then you do rollback. So transaction database, you have a begin, right? Begin. And then after begin, either you have option for commit or rollback. Okay. Yeah, similar to operating system like with this file system. So either you write in the new blocks and then make sure the writing is 100% correct, and then you update. Or if something wrong, and then you just do rollback, which is very cool. Next is checksum. So the checksum here is separated from the data. So sometimes when you read the data in the RAM and then in the file system are different. So for that, ZFS will provide checksum. Again, because the RAM consists of all the calculation here is based on the RAM, random access memory. So that's why the RAM itself is the critical point for the ZFS. So if the RAM itself is corrupted, and then all checksum is corrupted, so what you get is corrupted data. Okay, so that's why RAM, ECC RAM is very important for ZFS. Another feature, very cool feature, is self-healing data. So it means that, for example, with LVM or RAID, okay, RAID, right? Okay, so you have RAID 1. RAID 1 means mirror, okay? So you have hard disk here, you have hard disk there, and then mirror, okay? So this is hard disk 1, this is hard disk 2. So at the same time, you are writing into two hard disks at the same time, right? So because we do mirroring. So if one fails, okay, and then you just use you don't have to worry because the data still is replicable to hard disk number 2 here. But Sometimes they are not same. We have SDC, silent data corruption, okay, SDC. Because in one time, when you do reading, you can do reading from here, from one place only. And then at that time, okay, the sector here is bad. What you will get, garbage data. Yeah, that's true. But when we write, we are writing on the same time, a different hard disk and the same sector. Okay, but when we read, we just read from one hard disk, either hard disk number 1 here or hard disk number 2, only one. And then there is a possibility that on that hard disk we have a bad data. So with ZFS, okay, so ZFS mirror will detect. There is a possibility to detect the data. To detect the corruption on the mirror, okay, and then ZFS mirror will healing the bad copy. Okay, so first it checks and then compare here, and then rewrite the bad blocks. Okay. Oh yeah, it's done. So I think that's all for tonight. Perhaps I can do some demos here regarding with the operating ZFS file system. Okay, let me log in to the I cannot give you an access because this requires this one requires a root permission. So yeah, I cannot do that. On Linux, actually the ZFS here, the code is licensed under CDDL, CDDL license, CDDL license. So L must be licensed, right? CDDL, I forgot the acronym. Yeah, so with this license is not compatible with GPL. Okay, so Linux is GPL, CDDL is ZFS. Okay, so it means that ZFS cannot be integrated directly into Linux. Okay, cannot be in the Linux main kernel tree. So that's why ZFS is imported into FreeBSD, other BSD, and then other operating system. Okay, so if you want to use ZFS, I think the best implementation is on FreeBSD. On Linux, there is a implementation on Linux. It's called ZOL, ZFS on Linux. Okay, yeah. On Debian, you can just activate the you can install the Debian Debian module for ZFS. Okay, so so this is an example. Okay, so hopefully you can see my screen now. Okay, so this is ZFS. So do we have ZFS here? Oh no, it's not. Let me check. Okay, so we can install ZFS. Yes. Oh, we have to wait. Okay, perhaps we can access others. So those are the example of a ZFS, how you install the ZFS on Linux. So it's not, oops. It's not directly embedded into a Linux kernel. Yeah, you have to, work on that. Okay. Okay. Okay, any questions so far? So it's just that I need to, yeah, we need to wait for this one. Any questions? Okay, let me check in the group chat. Okay, can you share these materials? Yes, we will upload it on SlideShare. Okay, let me check again. Oh, it takes time. Okay, let's wait. Any questions so far? Okay, so first you create a Z pool, create pool 1, and then from SDH. Oh, oh, yeah, it has to be, yeah, in Linux, ZFS has to be merged into a kernel modules. Oops, what's going on? Okay. Okay, let's while we are waiting, let's discuss the topics. How about mount and unmount? Yes, it is possible. Yeah, mount and unmount. You can set up a mount lively. Okay, so ZFS set mount. See, mount into slash mount one, for example. And if there is no mount one directory, it will create that. The ZFS will create that automatically. For example, this one. So that's the command. Okay. For example, pull one, partition one. So this is the structure. Okay. So you have pool. Okay. Inside the pool, you have partition. Okay. So this is hard disk. Hard disk. This hard disk is ZFS. Okay. Based on this hard disk, you have pool. They call it Z pool. Okay, after Z pool, and then it's up to you. You have a partition. Okay, and then this partition is flexible. And then what you mount is this partition. Okay, with the ZFS command. So set mount mount whatever. So you can just here slash mount slash P1. But later on, you can change it slash blah, whatever. Yeah, it's possible. Sorry guys, the process here is very long. See here. So it looks like it tries to install the kernel modules of ZFS, and then it looks like it's stuck. Okay. Next, still watching. Okay, thank you. Since there is a new one for me, it's been established since a long time ago. Yes, 2006. Yeah, I was very happy when the ZFS is released. So we are very happy because it makes our hard disk management easier. Okay, that's the difference between ZFS and video. What is video? Can you explain? ZFS is file system. Video, I'm not sure what you mean by video. Is it related to a storage? Virtual data optimizer. Well, I think is it related to storage or not? Yeah, because ZFS, and I think this is the feature in Linux kernel. Because currently there is no file system that can match with the ZFS. Okay. Previously, Linux was proposing the B3 file system. Okay. Tries to compete with ZFS, but they failed. Until now, it's still experimental. Nobody wants to use it. Okay, it's failed. Sorry, guys. Linux. Yeah, but it's different. Okay. ZFS is different. Nothing to do with the B3FS or B3 file system or this video. Next, is it possible for me to try emulate ZFS in multiple home lab. Yes, 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 it's possible. Yeah. So one way for you to, because we are using virtualization also here. Yeah. I think the best thing, if you want to practice the ZFS, oh, now it works. Oh, okay, bad return status. See, guys, configure error. I don't know what to do here. Yeah, it seems like the ZFS implementation on Linux is not that stable, but you can try. Okay, if you want to try ZFS, you can use, okay, here are the options. Okay, one, use Solaris, but the Solaris itself is, because the implementation, the very stable implementation for ZFS is Solaris based, because it originates from Solaris. Okay. But you have to install this operating system, and then the Solaris operating system is not like Linux, you more manual. Okay, so maybe for you guys, that is new to the operating system, I don't recommend this. Okay, number two, you can use FreeBSD, because ZFS is already there. They just adopt the operating system, adopt the source code, and then put them into a FreeBSD kernel. Yeah, that can be an option. And then, yeah, all of them can use virtualization. Okay, yeah, you can use VMware, you can use Proxmox, I mean KVM, okay, KVM. KVM is one example of KVM implementation is Proxmox. I use Proxmox also, and then our Proxmox has 805 days without turning off. Okay, it's very stable. We like it. So it was VMware, KVM, or I don't know. Maybe you can use VirtualBox. Okay, you just put many hard disks there, and then yeah, you can play with the ZFS. All right, hopefully that answered questions. Muhammad Sefrian Ramza. Okay. Okay, thank you. You are welcome. Try using FreeBSD. Yes. Yes, BSD. But yeah, I think in the future, perhaps we can schedule FreeBSD operating system here. Not common in our project, but just for fun, we can install a FreeBSD. The thing that I don't like in FreeBSD is you have to compile the application from the source code, which can take a long of time. No, yeah, we use FreeBSD. Okay, anything else? Oh yeah, before I forgot, for those who are interested with the internship, okay, so we have an internship program here in our organization, and then the position for intern is only for developer, programmer. Okay, I will share the link on a group chat. Okay, so here it is. So the position is, yeah, the position here is for developer, okay, programmer. This is when we had our internship in Malaysia. So those are the interns, the students. Yeah, they are doing their internship in Malaysia. Okay, so if you are interested or your friend are interested, please apply. Okay, yeah, the location is online, and then yeah, make sure you have stable internet connection. Yeah, at least when we do a Zoom like this, there's no lag or uh, or having issue with the online connectivity, because everything will be based online. All right, guys. So again, if you plan to apply, we would like uh, uh, we are very happy with that. Okay, so you just apply, and then there will be an interview, and if you pass, and then you will do the internship. Okay, so I think that's all. Okay, um, another from admin is feedback. Please put your feedback here. And then the last one is, what is her message? Oh yeah, turn on your camera. Oh, okay, some of you already turned on. I mean the camera, not else. Okay, let me turn on the camera. Okay, guys, please turn on your camera. So we have a photo session here. Okay, I will count 1, 2, 3. Right. Okay, thumbs up. 1, 2, and 3. Great. Right, thank you very much, guys. I think that's all for tonight. And then next week, I think we're going to have two webinars. One is for GLC networks, and then also the other one is for PHP. It's PHP Programmer Indonesia. It's a community, PHP ID. It's a community, Indonesian community for PHP programmer. I'll be discussing data analytics in the database, with the database. Okay, if you are interested, you can come. And I think, yeah, that's all for now. Again, thank you very much. And yeah, as the last one, please put your feedback again. We really hope to get your feedback here to make us better. And yeah, if you're done, and then good evening, everyone. Again, please feedback.